So this video is going to give you a very brief introduction to the idea of symbol tables, also known as maps, also known as dictionaries, depending on the language you're in. Coming from Python, if you have that background, you probably talked about dictionaries. In Java, you'll hear about maps. C, also maps. Symbol tables, definitely in the book. The idea behind this is I kind of like this picture because you have the periodic table, which has symbols, which is a shorthand for you see these chemical formulas that are popping up. There's all these sort of shorthands that pop out of them, and it's the combination. There's a lot of meaning within the symbol. There's a lot of data that the symbol implies: the atomic weight, the structure of the element, all sorts of things. So the idea of the map or the symbol table is kind of like a vending machine. You can very much think of it as the old-fashioned vending machines where you didn't have computer screens, but you just walked up and you put in some random code. You couldn't just click on the food you wanted, in a touch screen. You'd have to say, okay, well, which one am I looking for? Oh, the Snickers is number 22 and the M&Ms is number 21, if you can see that on here. And you had to get your number right. There's nothing more disappointing than get the number wrong and the wrong thing pops out of it. The key does not necessarily have anything directly to do with the value, but it's just a correlation that somehow some magic code that gets you a shorthand to the item that you're looking for. Keys in general are shorthand. They're used in all sorts of things in life. In sports, we put numbers on players, even though some of these players are immediately recognizable. There's often, in sports at all levels, you have no idea who the people are. We use the key to identify the information on that player. Or, some very famous people go by single word names. Here Kanye and Madonna. You may or may not remember their last name, depending on if you're a fan or not. But that one name can stand out iconically for the person. It's a shorthand to more information about them. More practically, the maps generally in computing have some sort of organization as a quick lookup. You can think of it like an index or a tab system or that card catalog. There's many ways to cross-reference the same data, and maps can often be used in many ways. I can have a map on the same set of data several different ways to be able to look up different information as we're going to see. So, let's say the sports athletes right there. I could have a map that tracks them by their number. I could have a map that tracks them by the team they play for or by the position they play or all sorts of different things that can pull that data. I can say, hey, give me all the people who play a forward in soccer/football, or all forward in basketball, or whatever different sports on there. I can go to a orchestra and say, give me everybody who plays a clarinet or a viola or whatever instrument, and I can organize data in a lot of different ways, or I can organize it by everybody who plays string instruments, or I can again lots of different random ways to do that. The key behind the map, the dictionary, the symbol table, is its really quick ability to, after you've added data to it, to find the data. And so imagine, you needed to find a car in this jumble of mess. You would essentially, there's each car has a license plate. I could figure out which car I'm looking for, but I'd have to go car by car by car by car and look through each car individually. It'd be a very slow process. I mean, even this picture right here, you can't see all the license plates. You'd have to make sure you get one, ideally, probably one at a time until you've gone all the way through the process. Now, there are clever ways in computing systems we can arrange the data. So, for instance, since we know there's only a certain number of license plates out there in the world, we could have everybody park their car in a really, really big parking lot where they have an assigned parking spot based off of their license plate. Now, that gives us a really, really quick way to look up the car, but it's a very inefficient use of space. Unless I know that every single parking spot's going to be filled, like this parking lot, there's a lot of empty spaces. I might be wasting a lot of data hoping that a car comes along with that license plate, with that ID number. So really a lot of what we're going to be looking at over the next few weeks is the different strategies for searching data using clever data structures. The two main ones we're going to talk about is the use of hashing and the use of trees as strategies for implementing these maps. And so the one strategy we can talk about is having some specific little code, and you can see that in the left-hand side here, there's 4 bins, and we can have some magic code that tells you which bin to look in. So I can know things are either paper, plastic cans, or regular trash. And if you tell me it's a plastic, I just have to search, 25% of the items deposited instead of all of them. We'll learn about hashing, at some point here, and we'll come through that. The other strategy being trees, which trees gives us the advantage of being able to split the data to, basically reduce our search logarithmically, not just simply in half, but significantly faster than that. But it also has the advantage of it sorts the data at the same time. It gives us a little bit of advantage doing it that way. So that's really a lot of what data structures study is about. The thing that I want to spend some time on right now is the idea of using the maps. So again, we saw the traffic there, and the idea of the keys of that is how do I create data structures using these keys to be able to look up data quickly. So if I'm a police officer, I want to find out, hey, is that car registered? Who's the driver of the car? Where's that car from? Is there any outstanding warrants against the driver of the car? All sorts of things they find out about that. Just simply using this little key as a license plate. But there's all sorts of other ways to map out vehicles. I can map out vehicles by their VIN numbers, and that's a unique identifier. I can map it out by their year, their make, their model, the style of car they are. There's all sorts of different ways I can categorize something like an automobile, and that's what we're going to be talking about: is how do we use data structures to solve interesting problems, so that way we understand which is the appropriate data structures to use to solve the problems. But we understand the value of the speed and the trade-offs of the different data structures as we go forward. So that's really what I want you to think about. The rest of this video series is really getting into putting these maps into action, putting these data structures into action. And the raffle application will walk you through that directly so you can play with these ideas and build some interesting code, get some good practice, and earn some valuable points.